Dear students, today we are going to discuss formulae lecture for electrostatics. When we consider electrostatics, the first important formula is regarding Coulomb's law. According to this particular law, if there are two charges, static charges separated by finite distance r, then there is a force of attraction or repulsion between these two charges that is directly proportional to product of magnitude of charges and inversely proportional to square of distance between them. In the equality sign we can write this is as some constant 1 upon 4 pi epsilon 0 q1 q2 upon r square. This is Coulomb's law. This is force of attraction or repulsion depend on like or unlike charges, and this constant 1 upon 4 pi epsilon 0 is 9 into 10 raised to 9 Newton meter square per Coulomb square. This is very important, where epsilon 0 is permittivity of free space. Its value is 8.85 into 10 raised to minus 12 Coulomb square per Newton meter square. So Coulomb's law, the force of attraction or repulsion between two charges is directly proportional to product of magnitude of charges and inversely proportional to square of distance between them. In the equational format, we can write F is equal to 1 upon 4 pi epsilon 0 q1 q2 upon r square, where 1 upon 4 pi epsilon 0 is 9 into 10 raised to 9 Newton meter square per Coulomb square. Epsilon 0 is 8.85 into 10 raised to minus 12 Coulomb square per Newton meter square. Its dimension is very important. It is m minus 1, l minus 3, t4 and a2. This is minus 1342. m minus 1, l minus 3, t4, a2. This is dimension of permittivity of free space. This is first important formula. Then here we have second important formula, electric intensity. Electric intensity, it is a vector quantity directed away from positive charge. Electric intensity, it is a vector quantity directed away from positive charge. It is defined as force acting per unit positive charge or number of lines of force passing through unit area, or it is also defined as electric flux per unit area. So electric intensity is defined as force per unit positive charge, number of lines of force passing through unit area, electric flux per unit area. This is basic definition of electric intensity. Then we have different formulas for electric intensity as electric intensity is equal to force upon charge, it is equal to electric potential upon distance. Then electric intensity at any point situated near a charged sphere is q upon 1 upon 4 pi epsilon 0 q upon r square. Electric intensity at a distance r from charge q is E is equal to 1 upon 4 pi epsilon 0 q upon r square. Again, electric intensity is electric flux upon area. So this is phi upon A. Electric intensity is electric intensity at any point situated at a distance r from charge q is q upon 1 upon 4 pi epsilon 0 q upon r square. The same formula is for electric intensity at a distance r from the center of the sphere. E is equal to 1 upon 4 pi epsilon 0 q upon r square. Suppose that we have a sphere having radius capital R. Let O is its center. Suppose that we have 3 points, point A inside this sphere, point B on the surface of the sphere, and point C situated at a distance r smaller from the center of the sphere. Let us understand the situation. We are discussing Gauss's application for finding electric intensity due to a charged sphere. Suppose that Q is the charge situated on the surface of this sphere. We are discussing three cases, one for point inside, on the surface, and outside surface. So first important point is that inside any surface, closed surface, electric field is always 0, because charges reside on the surface, not inside the surface. So inside surface electric field is always 0. On the surface, that is at point B, electric intensity on the surface of the charged sphere is Q upon R square. This is important formula. And outside the charged sphere, 1 upon 4 pi epsilon 0 Q upon small r square. This is general formula for electric intensity at any point situated on the surface or outside the surface. Inside it is 0. We can write this formula in the another notation in such a way that sigma capital R square upon epsilon 0 small r square. Where what is sigma? Sigma is charge per unit area. Here we can write sigma is charge Q upon 4 pi epsilon 0, 4 pi r square. Sigma is charge per unit area. We can also write this is as capital R square. Sigma is charge per unit area, that is surface charge density. So this is important application of Gauss's theorem for electric intensity. Suppose that we have a cylinder having length small l, radius capital R. Let us find electric intensity at any point P situated at a distance small r from the axis of the cylinder. Electric intensity at any point P situated at a distance small r from the axis of the cylinder is E is equal to lambda upon 2 pi epsilon 0 r, or sigma capital R upon epsilon 0 small r, where capital R is radius of this particular cylinder, small r is the distance of the point where we are going to find electric intensity from the natural axis of the cylinder. And what is lambda? Lambda is charge per unit length. This is called as linear charge density. Linear charge density, that is coulomb per meter. This is surface charge density, that is coulomb per meter square. Charge per unit area, charge per unit length. So electric intensity at any point situated at a distance r from the natural axis of the cylinder, lambda upon 2 pi epsilon 0 r, or sigma r upon epsilon 0 r, where lambda is charge per unit length. Okay. Now suppose that we are having a plane lamina. So electric intensity at any point P dash on both sides of this particular lamina is E is equal to sigma upon 2 epsilon 0, where sigma is surface charge density of this plane lamina. The most important thing here we have to consider is that everywhere we are considering free space, air or vacuum. But if there is another medium, then at everywhere, every formula, we are going to attach dielectric constant K here, where K is dielectric constant of that medium. So electric intensity at any point situated near a charged sphere, charged cylinder, and this is plane lamina, is force upon charge, electric potential upon distance, it is electric flux upon area, it is 1 upon 4 pi epsilon 0 Q upon R square. For sphere, it is lambda upon 2 pi epsilon 0 R for cylinder, and sigma upon 2 epsilon 0 for plane lamina. These are different formulas for electric intensity. With the help of this formula, we can find SI unit of electric intensity, that is Newton per coulomb or Volt per meter. This is SI unit of electric intensity, and the dimensions are m1 l1 t minus 3 a minus 1. These are dimension of electric intensity. So this is what we are expecting, that you have to remember this formula in advance. Now let's move on to the next quantity, electric potential. If you want to have command over these formulas, you can go through these lectures 2 or 3 times and write all formulas at least 5 times. If you are going to revise it 2 or 3 times and all formulas at least 5 times, then definitely you will have a command over these formulas, and in the examination you will have no problem for recalling. You will immediately recall formulae and immediately solve the multiple choice questions. Now let's move on to the next quantity, electric potential. Electric potential, it is a scalar quantity. Second, electric potential is defined as work done in order to bring unit positive charge from infinity to that point. Suppose that we are going to define electric potential at any point due to charge q, then it is defined as work done in order to bring unit positive charge from infinity to that particular point where we are going to find electric potential. So electric potential is work upon charge. It's assigned it joule per coulomb. It is called as Volt. The dimensions are m1 l2 t minus 3 a minus 1. This is dimension for electric potential. Electric potential due to charge q at any point is having formula 1 upon 4 pi epsilon 0 q upon r. In electric intensity, this was r square. Here electric potential due to charge q 1 upon 4 pi epsilon 0 q upon r square. Now understand one thing is important here. Electric intensity and electric potential both represent strength of electric field. Electric intensity and electric potential both represent strength of electric field, and the important difference is that strength of electric field in terms of vector quantity is electric intensity. Strength of electric field in terms of scalar quantity is electric potential. Then we are going to find electric flux. Electric flux. What is electric flux? It is number of lines of force passing through or coming out normally through given surface area. When it was unit surface area, it is electric intensity or electric flux density. But what is electric flux? Number of lines of force passing through given area. And suppose that we have this area ds, say, let this is area vector ds bar. What is area vector? A vector drawn normal to any surface and directed outwards. So this is area vector drawn normal to this particular surface. Let E bar is the direction of electric intensity due to charge present over this surface, and let theta is angle between E bar and ds bar. Then electric flux d phi coming out through this particular surface area is dot product of electric intensity and area vector. As it is dot product of electric intensity and area vector, it is definitely a scalar quantity. So electric flux is also scalar quantity. It is dot product of electric intensity and area vector. So d phi can be written as E into ds into cos theta. Now there are two special cases. Suppose that electric intensity is parallel to ds bar. Electric intensity is parallel to ds bar means it is perpendicular to surface. So theta is 0 and d phi is equal to eds, because cos 0 is 1 and it is maximum value. So we can have here maximum flux. So जब भी इलेक्ट्रिक इंटेंसिटी दिए हुए सरफेस को परपेंडिकुलर होगी तो उस सरफेस में से मैक्सिमम फ्लक्स बाहर आएगा, और अगर इलेक्ट्रिक इंटेंसिटी सरफेस को पैरेलल हो गई, इसका मतलब एरिया वेक्टर को परपेंडिकुलर हो गई. इलेक्ट्रिक इंटेंसिटी सरफेस को पैरेलल हुई, एरिया वेक्टर को परपेंडिकुलर हो गई, तो थीटा 90 हो जाएगा, कॉस 90 0, तो इसमें से कोई भी फ्लक्स बाहर नहीं आएगा. और इलेक्ट्रिक फ्लक्स का यूनिट हम यहाँ से निकाल सकते हैं, न्यूटन मीटर स्क्वायर पर कूलम स्क्वायर. और इलेक्ट्रिक फ्लक्स का डायमेंशन ध्यान में रखें, m1 l3 t-3 a-1. सो दिस इज वेरी इंपॉर्टेंट यहाँ पर. सो इलेक्ट्रिक पोटेंशियल, इलेक्ट्रिक इंटेंसिटी, इलेक्ट्रिक फ्लक्स सारा हमने देखा. अभी और एक बार इंपॉर्टेंट पॉइंट रिवाइज करवाता हूं. इलेक्ट्रिक इंटेंसिटी, इलेक्ट्रिक पोटेंशियल, इलेक्ट्रिक फ्लक्स, ये तीनों क्वांटिटी ध्यान में रखना है. इसका यूनिट न्यूटन पर कूलम, इसका यूनिट वोल्ट, इसका यूनिट न्यूटन मीटर स्क्वायर पर कूलम, ये ध्यान में रखना है. इलेक्ट्रिक फ्लक्स का इसका जो डायमेंशन है वो m1 l1 t-3 a-1 होगा. इसका m1 l2 t-3 a-1 और इसका m1 l3 t-3 a-1. सो हम इसको इस तरह से भी रिमेंबर कर सकते हैं. 11 minus 31, 12 minus 31, 13 minus 31. This is electric flux, electric intensity, electric potential. And one important furthermore quantity is electric permittivity of free space. Its SI unit is coulomb square per Newton meter square and dimension are L-1, L-3, T4 and A2. So go through this particular lecture 2 or 3 times, write formulae 5 times. You will have a better command over the formulae.